Zero close off all valves. And open it. That was the third time. So now you can close it. Go ahead and run the recipe anyway. Yep. So that's the pump purge part of it. Now we want to go ahead and do the rate of rise like we did before. So go ahead, zero all close off all valves, and then open that. We're going to leave that open. Go to the vacuum screen. And then whenever you're ready, close the roughing valve. I'll start the timer. On the valve itself. Yep. And we're doing the same thing with the TMA as what we did with the water. Without a helium leak detector, this is the only thing you got. We started off with 50, you should be less than 10 whenever the reactor and everything's conditioned. So we just want to make sure we're not above 50.
So this is right now is TMA leak back into the system.
This is checking between the manual valve and where we connected it.
So the valve is still closed on both of
The
them?
manual valve is still closed. And so we're at 44. Still not greater than 50. The reason why there's a difference in the negative side is because it's still conditioning in the chamber. After the chamber's conditioned, then you won't see that drop anymore. It should say, okay, I started off at 1 and I went to 11 and I'm back to the same point. You should do that. If you were 10 millitorr or 300 millitorr greater than what you initially started before you attach anything, you got a leak. Go back to where you're at and find it. Now we did both ampules at the same time, so you know we might have had to go back and forth, but they both look okay for this point. So the rate of rise is something you're going to have to do whenever you load any ampule.
So the leak you were talking about is where you install the ampule to the
That's
system.
checking right here. If you look, there's a female VCR fitting here. This valve has a male nipple. So this is where we connected it. We want to make sure there's no leak between this valve and this valve. So first of all, we evacuated the atmosphere that was in that. That was a pump purge process. Then we compared the rate of rise before we loaded any ampules to the loaded ampules, and they were the same or better. So that gives us some degree above 80 percentile degree confidence that, okay, we don't have a leak there. But you could still have atmosphere here. If we filled it with water, we would still have atmosphere in this ampule. The TMA, that's new from the vendor, from Sigma Aldrich. Yeah, you didn't get it from Sigma Aldrich, I believe. But anyhow, that has packing gas, whether it be argon or nitrogen. We still got to get that out. Once that is out, if you take the ampule off and put it back on, you don't have to recondition it, as long as you have material in it. You don't have to do that. You have to do the pump purge, because you'll have atmosphere between the two from loading and unloading, but you won't have to do the conditioning of the ampule again. So, let me do a recipe check. Then how? Okay, we'll do it another way. There's normally a conditioning recipe that can do just the ampule itself, by itself. I'll have to get that recipe and load it on remotely. at some other time, or I might have it on my computer, I might look tomorrow. But we're gonna just run half of the recipe for the conditioning fluid. The recipe in itself, and I'm just gonna glance over this. You have a PR process recipe, this is aluminum oxide recipe. We'll be running this tomorrow. So we're gonna do a conditioning phase using this recipe, but we're gonna disable half of it.
Why?
We don't wanna do, you know, TMA and H2O. We just wanna do the TMA. Yeah. So, and whenever I get the other recipe, I'll load that, I'll explain that easier than what I'm going to do here. So, I'm going to run conditioning on just the water. The TMA, I'm going to make sure that valve's closed. And for noise purposes, and you can do this whenever you're checking things, if you're doing a dry run. Shut off the 3A valve, please.
The PC roughing valve?
On the deposition screen,
Yeah.
3A should still be open.
Next bottom.
Thank you. Okay. I just disconnected that from the ALD valve.
Oh.
You could do that for troubleshooting. In this case, I'm just doing it for an audible.
Yeah. Not as big as my previous.
I'll cover this in greater detail tomorrow. This is the aluminum oxide recipe, but we're only going to do the water part of it. So the manual valve on a TMA is still closed. I disabled the valve physically with the air line. You couldn't do that, or you can just leave it at not. I'm going to run this recipe. I'm going to lose you a little bit. Just bear with me. I'll cover more into this tomorrow. In a process recipe, it's going to do the population of the matrix here, so this is what you're going to see. Don't put a whole lot of thought into it, because again, I'm going to cover all this tomorrow. The TMA part of it, the TMA is disabled.
Right.
So I'm going to change this. I'll leave that as is. See, now as this is running, what it's doing is cycling both the valves. And if you go over there on 3A, you'll see that puff of air coming out because it's disabled. Now on, yeah, now it's going to do this valve here. There now. That shouldn't have happened.
That's fine.
I don't know what happened.
We got a bunch of interlocks there.
Yeah. I'm gonna take the compressors off. Patrick. So, okay. compressor wasn't on, so we lost the CDA. CDA being compressed dry air. Compressed dry air is one of the interlocks. This right here. This compressed dry air. So the compressed dry air has a switch. The switch, again I'll cover tomorrow, is right here.
No, excuse me. Oh, okay.
The switch is set at 65 psi. Okay, so it needs to have 65 psi. The other thing the system needs is to be pumping. So, you have to have compressed dry air, you have to have this vacuum switch on the reactor. These two will enable a safety circuit. This is the safety circuit. So to enable the safety circuit, click that, the safety comes on. What the safety circuit does, these two valves, these two solenoid valves, are controlled by this yellow box here called a banner. One of the things that banner controls. So you have two solenoids. If that safety circuit goes off, you have one solenoid that stops air coming into it, and the second solenoid vents any compressed air that might be going to the process valves. That's how the safety circuit works. What we seen, once the compressor wasn't on, we eventually used the compressed air up to the point that that CDA switch kicked off. The safety switch released at the same time we were doing that. So what I was doing didn't cause that. The lack of air got to the point where it caused it. So if you forget to turn the compressor on, that's what you're going to see. I thought it was on because we thought it was on earlier and just built up the pressure. So the pressure was up. It's just we didn't have to switch in the right spot. Notice all the heating stayed there. So the only thing that's affected by the safety circuit, process valves. Your gas flow, your argon gas flow will still remain going. So I'm going to go back to where we were at. Yep. I don't expect you to know anything about this yet. Manual valve still off on a TMA. Airline's off on the ALD valve if you choose. I have the cycle set for 50. Open the water.
The reason you take off the TMA valve is just for
The airline. So I know it's cycling. It's audible, I know that valve's kicking on, so I know the recipe's working. I'm just not introducing any chemistry. There's a recipe that'll do this faster than using the process recipe to do it. Right now I'm using the whole process recipe to do a 50 cycle conditioning of 1 ampere. There's a recipe I could set up that'll just do that ampere. I think I have that, I'm pretty sure I have that on my flash drive or my laptop. If I do, then I'll load that up tomorrow.
That's just for one.
Just for the conditioning, it's not a process recipe, it's just conditioning. So, right here is the water ampule. It populated the matrix. So you have, this is in milliseconds. So this is 10 seconds. This is really quick for this one. So you're not seeing this peak. You're only seeing, excuse me, one peak. This is just water. We're counting down to 50. So if this were a newly loaded water ampule, you'll see a curve. You'll see it drop out. In this case, it's not. I click this little setting thing and I can come here. And you could, that's not much of a help. These graphs are the same. Five's too big. Anyhow, the peaks are roughly the right height. So that's somewhat a steady state. That's how you know that atmosphere or packing gas is gone. When we do the TMA, we'll see a much greater curve. So since we're already at a steady state, this ampule was already used, it's already been conditioned. I don't need to run the 50 cycles. I'm going to shorten this process by doing, I'll add 14 to it. You do not want to just stop the recipe manually. You want it to finish gracefully in a recipe-like manner, because it sets up everything in a known state. If you go ahead and shut it off manually, then